is equal to, now midpoint, how do you find the coordinates of the midpoint? It's x1 plus x2, you divide that by 2, and then you also do the same, y1 plus y2, you divide that by 2. These are how you find the coordinates of the midpoint. Are you with me? So if I can just bring this closer so that you can actually see. So this is the formula for the coordinates of the midpoint. Now, similarly what I did previously, remember I said there is, when you're talking about coordinates, you must name them already. C is my x2 and y2. That is my C from the previous question. I can make this my x1 and my y1. So that I can say the gradient, the midpoint of EC, that's why I'm using the capital M, is x1. You can see it's 6. See that? That's my x1, which is 6, plus x2 is 4. I divide that by 2. I getting that? And then I've got the formula for the gradient of the y coordinate. It's y1, which is y, plus, and then y2 is negative 2 over 2. So this is the actual midpoint. Hello once again, our most valued student. My name is Confident and welcome to the revision session, and we are continuing to look at analytical geometry, and this is for grade 11 students. And as I said, it's paper 2 revision, and we have been looking at this paper which was written in 2019, paper 2, and I've been going through this paper in question by question. And as I said, most of you guys, I've discovered that when I bring in a question, I find that the question is long, and I would have loved to do the whole question in one video. It becomes too long, and because of that, it kind of makes you struggle to finish the whole video at one sitting. Why? Because whenever you are revising, you do not have to sit for a prolonged period of time. The maximum time you can sit per session, just give yourself 25 minutes maximum, and then take a break. Give yourself another 25 minutes again, take a break. When you do that, you are actually recalibrating your mind so that you can absorb more content. Now, because these videos were too long, what I did is I will be going through each and every question, but I'll be breaking it into smaller videos which you can now easily follow. So if a video is too long, you'll discover that I'm going to be breaking it into small sections. So as I said, check out question 1 of this video. You'll go on to check out question 2. If it's not available, I'll be loading it shortly, but just check our video. That's why I encourage students to subscribe. Why? Because when you're subscribed, you are easily notified by YouTube to say, check out, there's a new video for grade 11, and you can quickly check to discover that it is those questions that you are looking for or looking forward as you are doing your revision. So it's very important for you to subscribe. So this question might be already available. If not, check it out. But my reason for being in this video is to do question number 3. Look at this question. Is on analytical geometry, and as I said, I'm gonna do it in one sitting. All these questions will be done once, but when you are revising, you will see that I'm going to break them into small sections. So it's not gonna make sense for you to start watching the second video if you did not start with the first video, because sometimes some of these questions, the answer from the previous question will be needed to continue for the next question. So it's gonna be difficult, but I will encourage you then to follow up, subscribe right now, and also very important, share the channel with your friends and your colleagues. Let's look at question number 3 here. And in question number 3, what are we having? It says, in the diagram, A, which is these coordinates, and we can actually follow up while we are reading this. So what we have got A with those coordinates. We've got B, I think B is below, which is -4, -6. These are the coordinates. We have C, and also there is 4 minus 6, and then we have and E. Okay, there is not D. We're given the E there, which 6y. They're saying at the vertices of a quadrilateral having AE, you can see there is the AE part, and they are telling us that it is parallel to BC, okay, such that AD is perpendicular to BC. So there is AD perpendicular to BC. There is the 90 degree there, and AC is drawn. And AC is drawn. Okay, we can see A and C there, and then M, which is x2 coordinates, is a point on EC. All right, let's get this done. 3.1 says calculate the gradient of BC. Now we want the gradient of BC. Now with analytical geometry, you are heavily reliant on formulas. So whenever they are bringing in a question, you need in a way to always recall your formula. So when they're talking about the gradient, you must know the formula for the gradient. So we'll call it gradient of BC because they're saying M of BC. I'm writing actually AB. So gradient of BC is equal to, it's y2 minus y1 over x2 minus x1. This is the formula for the gradient. Now we come to B. We can actually say let B be x and y. Those are coordinates, right? But we'll call it x1, y1. And then C will then become our x2 and y2. I think that because I'm looking at that gradient. So if I can say now gradient of BC, it is equal to y2, which is my -2, minus y1, which is my -6. Now be careful. I've got a negative from the formula here, but also I've got -6. So you put that -6 like that. Don't make an error. It's -2 minus -6. Where are the two negatives from? There's the negative from -6, and there's the negative from the formula. All right, and then over x2, as you can see, it's x2 is 4 minus again x1 is -4. So the proper procedure is to put a bracket and say -4 like that. But even if you didn't put these brackets, the calculator will still give you an answer. So gradient of BC then will become, and then avoid this thing of avoiding using the calculator. The calculator is your guy. As I say, -2 minus -6. Even if you did that, you still get your answer. All right, and then 4 minus -4. And then the gradient is 1/2. But even if you put the brackets, it's still going to give you the answer. The proper way is to put the brackets. So there is the gradient, it's 1/2. Now you need to understand gradients. If you see a line having slanting from the left, that is from the left to the right, it's positive gradient. If it was a negative gradient, you expect negative gradient to be a line in that inclination. So you need to also see that it does make sense. That's all I'm saying. So this gradient, as you can see, that it is making sense. Gradient of BC is 1/2. How many marks? You get 3 marks. I think it's just good for that. So let me write this to say BC is 1/2. Now 3.3.2, they're saying if M is the midpoint of EC, let's look at that. M, there is the M here. It is the midpoint of EC. You can see that. And then they are saying determine the values of X and Y. So let's come here and look at what they're saying. They are saying you are given M being the midpoint, and by a midpoint, the moment they say midpoint, let me come back here. The moment they use the word midpoint, you also need to know what is the formula for finding the midpoint, and then you know to say the midpoint. I use a capital now. Don't use small m. I'll say midpoint of what? EC is equal to, now midpoint, how do you find the coordinates of the midpoint? It's x1 plus x2. You divide that by 2. and then you also do the same. Y1 plus Y2, you divide that by 2. These are how you find the coordinates of the midpoint. Are you with me? So if I can just bring this closer so that you can actually see. So this is the formula for the coordinates of the midpoint. Now, similarly what I did previously, remember I said there is, when you're talking about coordinates, you must name them already. C is my x2 and y2. That is my C from the previous question. I can make this my x1 and my y1. So that I can say the gradient, the midpoint of EC, that's why I'm using the capital M, is x1. You can see it's 6. See that? That's my x1, which is 6, plus x2 is 4. I divide that by 2. I'm getting that. And then I've got the formula for the gradient of the y coordinate. It's y1, which is y, plus, and then y2 is negative 2 over 2. So this is the actual midpoint. Now, the question is here, we need to find the values of x and y. So how do you do this? Look at this now. But I'm told that the actual gradient m, which is this part, that gradient is equal to, is not actually, I can say equal to, the actual coordinates, not gradient, is equal to x and 2. These are the actual coordinates. So what do? You actually match them to say, if I'm to divide them, this x is that and this y is that. Are you seeing that? That's how you actually solve this question, to say, if you were to divide this, the actual x value belongs to that part. You see that? So here, what is my x? X is equal to 6 plus 4 over 2. Now, what is 6 plus 4 over 2? This is 10 over 2. X is equal to 5. I think that. And then the same thing with y. You're going to say y, let me do it down. Y, that is plus minus 2, so the negative is powerful there. It overrides that positive. Y minus 2 over 2 is equal to, it's represented by 2. See that? That's how you simplify that. And then you multiply by 2 this side, multiply by 2 to remove that fraction. So what do you have? You've got y minus 2 is equal to 2 times 2 is what? Is 4. Take negative 2 to the other side. You've got y is equal to 4 plus 2, and you have got y is equal to 6. So these are the coordinates there. So here y is equal to 6. So the coordinates in this case, how do you write them? The coordinates of m, or actually not the coordinates, the values of m, of x and y is equal to what? 5 and 6. That's what they wanted. They wanted you to find the values of x and y. It's 5 and 6. All right. So if I can write it down here to say, here x is equal to 5, y is equal to 6. Now it just makes sense out of it. Are they positive? You can see that x, yes, is positive. It's not really drawn to scale, but if c was 4, you can see that this can be 6. It makes sense because the x value of c is 4, and then y is 5, also positive, and it does make sense. This is 5, to say it can actually make sense. All right, now next one, calculate the length of BC. The length of BC. So here they are actually bringing in the formulas. If you can look at what they're trying to bring in, is they started number 1 with the gradient. Now they are looking at the midpoint. Now they are looking at the what? They are looking at the distance formula. So they want you to find the the length of BC. I'll still do the same thing here to say already I've got my B, and with my B here I've got x1 and y1 on B, and then on C I'll have my x2 and y2. What is important is to recall the distance formula. What is the distance formula? D is equal to square root of what? X1, it's x1 minus x2 squared, I think that, plus y1 minus y2 squared. It doesn't matter. I can start with 2 here to say x2 minus x1 squared, and then you must maintain. If you start with x1, you must also start with y1. That's all. Someone can say d is equal to square root of y2 minus x2, not y, x2 minus x1. But the moment you start with x2 minus x1 squared, you say plus. You cannot start with y1 now. You must maintain and say x2 for y2. You see the difference? Minus y1 squared. You just have to choose. Both of them, they will still give you the same answer. Let me choose the first one. Then it will be d is equal to square root. I'll use the first one here. So x1, you can see is minus 4 bracket minus 4, and then x1 minus x2 minus 4 squared plus y1, which is negative 6 in brackets, and then y2 is minus. So there is minus on the formula, and then there is minus 2. So there is 2 negative squared. Okay, so you can see that negative is a positive. So, but the calculator will do that for you. It's square root of what? As I keep on saying, rely on your calculator there. So it's square root of bracket negative 4, then minus 4 squared, and then plus negative 6 minus negative 2 squared. The calculator will still solve that for you. You don't have to struggle. And then you've got 4 root 5. So you've got here 4 square root 5. That is the answer there, 4 square root 5. So the question was distance of what? Calculate the length of BC. So distance of BC. So 4 root 5, you can actually simplify that. I think they say it will leave our answer to 2 decimal places. So you can use that to say what is 4 square root 5. It's equal to, and then press ST, 8,94 units. So it's 8,94 units, because we don't know whatever units they are using. Alright, calculate the length of BC. So far so good. And then let's look at 3.4. Says if it is further given that AE is equal to square root of 80. So let's look at AE. This is the distance AE. So they're saying it is AE is equal to what? Square root of 80. To which group of special quadrilaterals does ABCE belong? So now let's look at what is square root of 80. If you say square root of 80 equal to, you see, I'm still getting also the same answer I got for BC, which is 4 root 5. So here, square root of 80 is same as 4 square root 5. And BC was also 4 square root 5. So if you come here on our diagram, you can actually see something here that is unique. You can see that BC is equal to AC. That's the first part. So you're like, this one is equal to that one. And at the same time, they are parallel. You understand? So if the two opposite lines are equal and parallel, obviously these other two lines also will be equal. That is AB and EC. They'll be equal as well as what? As well as parallel. That's one thing that you need to know. And what we call such a shape, it's a parallelogram, because they're asking which group. So does it belong? So this is a parallelogram. Alright, so guys, as I said, I'll be doing these videos in bits and bits. So I'm continuing with this video, but at this point I'm gonna cut it here. So if you're continuing with me, you will have to continue with me in the next session. But currently this is where I'm ending in the first questions, which is 3.1, 3.2, 3.3 and 3.4. So what you need to do, ensure that you are subscribed so that you can watch the next coming video, which will be 3.5, 3.6 and 3.7, and then you get what? You get 20 marks. As I said, the aim of this is to enable you to watch this video in one sitting. That's why the actual name of this channel is called 24-minute lesson. Why is it 24-minute lesson? Because it takes you around 25 minutes maximum for you to be at the best kind of state to understand what you're reading. Otherwise, if you stay too long trying to study, you end up wasting time, I would say. So don't waste time. Sit for a short period of time and then get out of your room or wherever you're studying and just get some fresh air. Don't look at your phone. Don't do anything that needs your mind. Just do something totally different. Go out, laugh with some family and friends, and then come back again after 5-10 minutes and continue with your studies. So if you wanted, for example, to do this question 3, so you're going to do it in 2 sittings. You do the first one, go out, come back again, and watch the second video. We've come to the end of this lesson for now. Now continue with me in the next lesson.